In this video, I'll be going over my solutions to Google Code Jam Round 1A. So starting with the first problem. Let's start by considering the case where all of the given strings start and end with an asterisk. All of the given patterns start and end with asterisk. So like these strings, they all start and end with an asterisk. And in this case, we can always find the answer. So in order to get the answer, what we can do is we'll just go through each string and go through all of the letters in order and just add the letters to the answer. So one possible answer for this set of patterns is just A, B, C, D, E, F, A, and then H, I. And this will always work when we have an asterisk at the beginning and at the end of each pattern. So now the more interesting case is when there can be extra letters at the beginning and at the end of each pattern. So like this. So in this case, what we'll do is first we'll find the prefix and the suffix, the longest prefix and longest suffix for each pattern that doesn't contain an asterisk, and we'll remove those from the patterns. Then out of those, we'll look at the longest of such prefixes and the longest of such suffixes. So longest prefix is AB. The longest suffix is YZ. And then in order to get the answer, what we'll do is we'll just take the longest prefix and then we'll add we'll add the letters in the middle like the case before. So we add A, B, C, D, E, F, A, H, I. And then we'll end with the longest suffix. Okay, and then this will give us our answer. But this doesn't work in the case, this won't work in some cases. So for example, if there was a C here, then it would be impossible to match the C with the two A's in the beginning. So we need to check if it's possible to match the prefix and the suffixes. So after we have our longest prefix, what we do is we take the other prefixes, so A and C, and then we just, for each of the other prefixes, we need to make sure that they occur as a prefix of the longest prefix. So A is a prefix of AB, so A is fine. But then C is not a prefix of AB, so then it shows that this set of patterns does not have any solutions. So for the code, it's pretty simple. So we just input each pattern, and then the first thing we do is remove the prefix and suffix of each pattern. So the first for loop basically does while the first character in the pattern is not an asterisk, we'll add that character to the prefix, and then we'll remove that character from the pattern. The second for loop does a similar thing, but for the suffix. So if the ending character of the pattern is not an asterisk, then we'll add it to the suffix and we'll remove the character from the pattern. Then lastly, while inputting all of the strings, we'll maintain the index of the longest prefix and the longest suffix. So these two if statements will check for the longest prefix and the longest suffix. Then to check if an answer exists, we basically just go through each prefix and each suffix. And the first if statement checks that the prefix of the longest prefix is equal. It checks that the prefix of the current pattern is a prefix of the longest prefix. So you basically take the substring starting from 0 all the way to the length of the current prefix. And if these two strings are not the same, and that means that we have the case where a prefix of a pattern is it doesn't coincide with the longest prefix. So then there's no solution and we just return. And we do a similar thing for the suffix. So we need to check that suffix of the current pattern is a suffix of the longest suffix. So to find the suffix of the longest suffix, we start from the index, which is the size of the longest suffix minus the size of the current suffix. And lastly, if we find that all prefixes and suffixes match, then we'll just start building the answer. And the answer starts with the longest prefix, and in the middle there are just the letters from all the patterns, which this for loop does, and then we add the longest suffix to the answer and we output the answer. Yeah. And now I'll go over B. So for problem B, so it tells you the definition of a Pascal triangle, and so you need to know one important property of the Pascal triangle, and is that, so you have rows starting from 1 and 2, 3, and then I choose, and then 230, and it also goes on. I just stop at 30 because I'll explain later. So if you sum up the rows, then you'll find out that there are powers of 2. So in row R, we will get a sum of 2 to the R minus 1. And this is really useful to us. So n can be up to 10 to the 9, but we can only use our walk can have a length of at most 500 cells. So what we'll try to do is, our main goal is to convert n into some binary number, and then the binary number will consist of powers of 2, and we'll basically try to we'll try to get a sum of n by traversing the rows. So if we wanted this power of 2, then we would just traverse this entire row, and if we want this power of 2, then we would traverse row 5. Yeah, but then the problem is, if we can't only traverse these two, because these two are separate. So what we can do to try to fix this is, we will start from here and then we'll move down here, and then since we need to traverse the entire row 2, we'll just move here, and then we'll move down here, and then once we get to row 5, we'll traverse the entire row. And this will give us this will allow us to traverse row 2 and row 5, but then we also end up visiting some unnecessary cells along the way. So in order to fix that, first let's just assume that we will already traverse exactly one cell in each of the 30 rows, and I choose 30 because 2 to the 30th is the smallest power of 2 greater than 10 to the 9. So what we need to do first is we subtract 30 from n, and then we consider n minus 30, because we already traversed we already used 30 cells, and each of them has a value of 1. And then what we can choose to do is when we reach some row, we can choose to traverse that row and end up on the other side. And then in this case, we would end up here on the right. And then we can also move left back again in some other row, and we can move back and forth as many times as we want to. So if we calculate the sum of the values that we will traverse, since we traverse exactly one cell from each of the 30 rows, so we start with 30, and then let's say that we traverse through the rows R1, R2, all the way to RK. Then for each row we go through, we will add an additional 2 to the R1 minus 1. We'll add this additional value. So and we want this to be equal to n. And we can, as I said earlier, we just move the 30 to the other side. And this is very similar to it would be very nice if we could ignore the minus 1, because if we could ignore the minus 1, then what we'll do is we'll just calculate n minus 30 in its binary representation, and then we can just choose R1, R2, all the way to RK to be, we'll choose them to be the set bits of n minus 30 in its binary representation. And the way we fix this is, what we'll do is, after row 30, we'll go down an additional k rows. So that means we'll add k to the entire sum, and that means we add 1 to each of the terms when we go down an additional k rows. So then our total sum becomes this thing, which is really easy to work with. So it's just the sum of powers of 2. And you want it to be equal to n minus 30. And now we can simply just take the binary representation of n minus 30 to calculate the rows that we pass through. And yeah, that's pretty much it. And there's also the case when n is less than 30. If n is less than 30, then we can just do a really simple construction where we just go down n rows because n is really small. And also you might be wondering how many moves this takes. This strategy is definitely better than just going down n rows, but we want to make sure that it takes at most 500 steps. So if we traverse each row, we have a total of 30 rows, and if we traverse each row, then we'll end up using 1 step in the first row, 2 steps in the second row, and so on. And then k might also be up to 30, so we add additional 30. And then I'm pretty sure if you calculate this, it turns out to be less than 500. So yeah, and then I'll show the code right now. So the first thing is, if n is less than 30, we'll just go down the row on the left side n times, which is there's nothing to worry about this. So if n is greater than or equal to 30, then we subtract 30 from n. And then my m here, it actually represents k here. So for each of the rows, first I move to that row. So I move to row I plus 1, and then this boolean stores if I'm on the left side of the row or the right side of the row, and this boolean will change when I go through the rows. So if I'm on the left side, then the column will be 1, otherwise it's just the number of the row, which is I plus 1. And then this if statement checks if the ith bit of n is set. So if the ith bit of n is set, then that means we need to traverse the row to add 2 to the I minus 1. And yeah, so we'll traverse the row, and if we start from the left side, then we just go from 1 to I. And if we start from the right side, then you go from minus 1 to 0. And then after we traverse the row, if we just negate left, because if we are on the left side, we are now at the right side, and vice versa. So then we add 1 to k, so that we can add these values later on. And then lastly, we just process the extra k rows that we need to go through, which is similar to the statement here. So yeah. Okay, the last problem. Shoot. Okay, it turns out I had a small bug in my code, but now it's fixed. So, okay, so for this problem is really just about simulating the entire process efficiently. So I think there's not much to explain except for the code. So what I'll do first is I just input all of the data, and then we'll store all of the competitors which haven't been eliminated yet in linked list. So for each row and for each column, we'll store a linked list, a doubly linked list. And for each cell inside the matrix, we'll store the left neighbor, the right neighbor. This is for the rows, and then for the columns, we'll store the neighbor to the top and the neighbor to the bottom, so up and down. And then at the start, all competitors haven't been eliminated yet, so the left neighbor is just j minus 1, and then the right neighbor is just j plus 1. And I check if j is less than n minus 1, because if there's no right neighbor, then I want it to be -1. And similar logic applies for the last two, applies for up and down. So then throughout the process, I'll maintain the sum of all of the competitors which are alive. So initially everyone is alive, so I just add up the s value for everyone. And then I'll also calculate initially like which competitors will be eliminated after the next round, which I'll do with this function check2. And this function called check2 calls check. So what this check function does is it returns if the person should be eliminated or not. And the way it does it is just goes through each of the neighbors at the left, right, up, down, and then if the neighbor exists, which I check using this, so this will be true if this is not -1. And then if the neighbor exists, then I add 1 to the number, and I add the s value to the sum. And then basically I just check if the s value of the current person is less than the average of the sum of the s values of the neighbors or not. So I just use this expression to check, and that the average is sc divided by nc, but since I only want to work with integers, I multiply both sides by nc. And then so after I check if cell ij should be eliminated, if it should be eliminated, then I'll insert it into the set, and this set will store all of the cells which should be removed after the current round. And then otherwise, if it should not be removed, then I'll erase it from the set. Okay, so yeah, so this will tell me, this part will tell me, will calculate which competitors should be removed after the first round. And then the simulation starts. So the ch variable stores if there's a change or not. And if there's no change, then we'll basically just end. So there needs to be a change for the loop to continue. And then at first there's no change, and then we add the sum of the competitors which haven't been eliminated yet into the answer, and that'll be the that will be the interest level of the current round. And then we'll go through each of the cells that we are supposed to remove. So first we set change to true because some cell is removed. And then also the sum of the cells which have not been eliminated yet will be decreased because we're removing the current cell. And then for each of the neighbors, what we'll do is first we'll update the linked list for the rows and the columns. And this is a pretty standard process of removing a node from a linked list. So the right neighbor of the left node will be set to the right node, and the left neighbor of the right node will be set to the left node of the current node. The left neighbor of the current node. So the first statement updates the linked list for the row or the column, and then the second statement checks because we remove the current cell, that means the neighbor's average might change. So we need to check if we should remove the neighbor or not. So that's why we call check to for the neighbor for the second statement. And lastly, we shouldn't remove the current cell again because we already removed it. So if the cell ij exists in the set that we need to remove, exists in the set that we're supposed to remove in the next round, then we just erase the current cell from that set. And yeah, this is basically it. So I'll include my codes in my GitHub, and I will post the link in the description below. And hopefully this was helpful to you. And if you have any questions, then you can ask them in the comments below. I'll try to look through them, or you could go on to my Discord and see if anyone wants to help.